So I guess I should introduce myself.
Thank you,
I'm
Dan.
Dan Kernler. I'm the president-elect of IMACC. It hasn't really hit me yet. So, but that starts officially in like a week. So, and I'm here to host this session. We have Julius Nadas from City Colleges, specifically, which one, remind me, Julius?
Wilbur Wright.
Okay.
Wilbur Wright.
Wilbur Wright.
Yes.
And he is here to talk to us. What is the official title here? It is We Need to Teach Useful Gen Ed Math. So he's going to give his presentation. And all right, I'll just pass it off to you, Julius. I'm going to spotlight you if you just want to chat for a little bit, and then your screen will pop up whenever you are ready.
You asked which college I was in. I was in Wilbur Wright. Why Wilbur and why not Wilbur and Orville Wright? Because Orville hadn't been dead long enough to be allowed to be named, have a college named after him. If he would have died sooner, we would have had a Wilbur and Orville Wright College. And that's useful math. Anyway, what I'm going to do is I'm going to put a PowerPoint presentation, share it. If it doesn't work for you guys, would you please let me know? So here it is, share. And the question is, what is math good for, right? We have all these students who are required to take a math course. And then when they come to you and they ask you, what's this is good for? You tell them, well, this is good because I need the job. Maybe not. Why is it good? We don't know. Anyway, what I'm going to look at is math and English skills determine whether you are college ready. But the problem is, are these math skills totally arbitrary, or are they something that you're going to actually use later on, either in other classes or on the job? If you think of math as juggling numbers, do you really need to have juggling required for everything if you want to be a circus performer? I've got a lot of TED Talks that have actually said that math is a barrier to higher education. It actually contributes to inequity in our society. If you remember the first presentation we heard, we're looking at trying to have equity for our students. Well, it turns out that math is the one thing that scares them and keeps them from completing, in some cases, even from starting. Remember, we're not talking about STEM students. We're talking about students who really are afraid of math, who don't want to do anything at all that's going to confuse them. And we're forcing them to take a math course. So what I'm going to try to do today is to try to explain to you what would be useful and what we should replace our current educational math with. So what is math like now? How other fields have changed? And what math should be. Warning, this is information that does not represent my college. So if any of you think that Wilbur Wright College or City College of Chicago agrees with what I'm going to tell you, let me disillusion you. They are drastically opposed to what I'm going to say. And I was telling Dan that I want you people unmuted so that we could maybe have a little interaction so people can tell me that I'm wrong and explain to me why I'm wrong. Anyway, we're talking about other fields. Every other field in the college is now using computers very frequently. If you're taking a business course, you have to know how to use Excel. If you're taking biology, everybody is now using computers. Our math teachers don't want you using a computer in the classroom because they know the computer will give you the answers, because the questions they're making up are the kind of questions that computers are good for. They're not things that I think we should be teaching them. So right now we're memorizing, reciting, doing manual calculations and word problems. 30 days has September, April, June, and November. All the rest have 31, excepting February alone. And that has 28 days clear and 29 in each leap year. Do students actually have to memorize this? Does it make sense for them to have to tell you this on a test? Why can't they just pull out their phone, look at their calendar, and it will give them all this information? What I'm suggesting is that we're wasting our students' time. We're not trying to prepare them to go on a time ship to go back to 1950 where they needed to know this. We're trying to prepare them for going forward. And this is not information that they need going forward. 3 times 5 is 15. 4 times 5 is 20. 5 times 5 is 25. I remember when I was in the second grade, my mother forced me to memorize the multiplication tables all the way up to 19 times 19. And I'm looking at her and saying, why? There are places I can get this information. Why do you want me to know this? Well, you're going to need to know this in school. Yeah, sure. And when we're doing something more complicated, like multiplying 315 by 826, instead of using technology in a typical math course in grade school, you multiply a bunch of stuff and then you add up the products. Do you know what would happen to an accountant if he pulled out a piece of paper and started doing calculations on paper using this procedure? He'd be fired like that. So what are we preparing our students for? Not to be ready for technology? Word problems. That's another one I love. If Johnny has 4 apples, right? And Mary gives him 5, what does Johnny have? Very big hands. I want my students to think about a question and understand what's being asked for in ways that make sense. I don't want them memorizing things. Typically in a grade school environment, a teacher will give them this problem and they say, you got 4 apples, 5 more will give you 9 apples. Okay, now what if Johnny had 3 apples and Mary gave him 2? What are we trying to do? Program our children to be better than computers? No, that doesn't make any sense. Basic principles. The math teachers in my school think that there are some beautiful principles that mathematics represents, and it's very important for these students to get a good feel for them. I had a brother-in-law who had an atelier, an art school up in Minneapolis. He says all great painters should be trained to recognize perspective, novel realism, and all kinds of other stuff that he taught in his art school. Wait a second, what about people who are going to be painting houses? Aren't there more of them? How are we going to train them? All great mathematicians are trained in the beautiful principles of algebra and calculus. What about our students? Will they really need these principles in other disciplines or on the job? And my answer is no, no, no. State of knowledge today. What children don't know today is how to read an analog clock. You notice they're taking the analog clocks out of the schools because kids can't look at the clock and tell what time it is. Writing cursive, no longer a requirement. Do you know that there was a survey done here in Cook County about why people were not submitting absentee ballots? Because they didn't know how to buy and use postage stamps, hourglasses, paper maps. So we're looking at the new skills that they've picked up. Everybody knows how to use Zoom to get into their classroom, but they don't know how to use the stuff that they had to use 50 years ago. What does it mean to know math? Counting, for example. You got your fingers, 1, 2, 3, 4, 5, left hand, 1, 2, 3, 4, 5. Now, just as a background to all of this, one of the reasons you may not appreciate what I'm saying is because I am an immigrant. English is my third language. When I came to this country, I was very, very confused because I'm trying to learn stuff that I already know. Counting in my language. Each one of those words looks and sounds the same. I come here and they tell me, this is the word for one. It's spelled O-N-E, but it's pronounced with a W, as in W-O-N. What are they doing to me? Then I said, okay, forget that. Let's go on to the next number. The next number is spelled T-W-O. There's a W in there, isn't there? Why do we pronounce it like T-O-O? Anyway, I gave up at that point. If you don't understand what I'm saying, call it a language problem. English is my third language, and I've never really quite mastered it. Back in the old days, knowing math meant you knew how to add, multiply. And in fact, teaching math has not changed in hundreds of years. If you go to the grade school, you'll find that many of the teachers are teaching the same way they learned 30, 40, 50 years ago. I'm saying that memorizing a series of steps to solve a problem by hand is not critical thinking. Critical thinking is looking at a problem, understanding what's being asked, and then coming up with some way of getting an answer. Other fields have added technology to their teaching. You've got simulated labs in the sciences, spreadsheets and databases in business, CAD in architecture, SolidWorks in manufacturing technology, online library database research in humanities and social sciences, word processing and PowerPoint for all students. But for some reason, if you walk into a math class, they don't want you using computers. They want you to understand what's going on. And I say baloney. What we should be doing are using smartphones and apps. You may not be familiar with these two apps. These are two of my favorites. PhotoMath, for example. You take a picture of a problem, it will analyze the problem, give you the steps for the solution, and display it for you. I've got some grandchildren who've learned from various sources that if they just take a picture of a problem, copy down the answer, the teacher will say, "Oh, this is great. I'm so glad you knew the steps." No, the kid doesn't know how to do those steps. All he knows is how to get his smartphone to take a picture and give him the answer. Wolfram Alpha, that's another app which I think is fantastic. All they show here is Wolfram Alpha doing math problems. Actually, Wolfram Alpha will take any question in the world and try to give you an answer, because that's how Wolfram is. Okay, so now what do I think we need? We need math students to be able to look at a problem, to understand the vocabulary of the problem. If they don't understand the vocabulary, they should look up the words, figure out what is being asked for, determine the relationship between that and the given information, come up with a way to get the answer. Not actually get the answer, just come up with a way. So now, one of the problems we do in my math class right now is trying to figure out how many relay teams can you create out of 8 students. The relay team has to have 4 people on it. They come up with a number of NCR. How many ways can you put 4 people out of 8? Answer I say is no. You have to research the concept. A relay team is one that has a first person, second, third, and fourth. And depending on how you arrange those, you're going to get different results. So order does matter. You can't use combinations, you have to use permutations.
Julius, there's a
Yeah.
couple of questions
Yes, go
that
ahead.
came up. So one of them, I think both Ted and William were asking about the apps and using the apps. So William had asked about, so if a student is using the PhotoMath, do they never actually do the problem? And I think you're addressing this now. And then Ted also asked, like, is this considered cheating to you if the students are using the apps?
No, it is not cheating. The fact that they're able to do this is what I'm trying to get them to do, is to find the appropriate app. I am not programming them and saying, here's the app, here's where you put the data, here's how you get the answer. I'm giving them a question. I'm having them try to figure out what to do with that question. So in my class, the emphasis is on understanding the problem, not in coming up with the answer. Is that helpful?
And I'll let them, the chat has been quiet, so I don't know if that's good, good or bad.
Basically, if I talk loud enough, they're not going to ask me any more questions, right? In my class, I require that every math student should have at least one of the following: a smartphone, a laptop computer, a tablet, a netbook, a calculator. You have to use calculators or something in my class. But I
Scientific or graphing calculator?
don't care.
Okay.
Graphing calculators are probably much more complicated than anything that we would use in a gen ed math course. But if that's what you have, because somebody told you to go out and buy a high-end TI because that was going to help you, I'm not going to tell you to throw it away. Of course, we can then talk about it in class. And a lot of times I will demonstrate for the whole class how much harder that calculator is to use than something else that could give you answers in a more reasonable way. So today's math students should get familiar with the current apps. I prefer the ones that are online, like PhotoMath, Wolfram Alpha, or Desmos, or something called Wright Calc. Wright Calc is an app I wrote, and it actually practically holds their hands and gives them answers, but it doesn't, it requires that they understand what they're doing. And we're going to start looking at that in a little while.
I got another one here for you, Julius.
Yes.
So America asked about the technology in the classroom, and one of the options was the smartphone. So the question was, how do you control students trying to find the answers by texting their cousin? That's
Don't
my
care.
only major concern with using network technology.
I don't care. Let's talk about working on a job. If you're on the job and your boss tells you to do something, does he care that you're going to call your mother and say, "Hey, Ma, how do I find out how many square feet there are in a square yard?" As long as you understand the question, I don't care whether you text your neighbor. Now, let's think about this for a second. If your neighbor is actually helping you, that's going to potentially hurt his standing in the class, because grades are based on how well you did compared to the rest of the class. And I explained to them that, sure, it's okay to ask for help, but don't ask your neighbor, because they don't get anything out of this. On the other hand, most of my tests are ones where each student has different numbers in the question. So if ask you how much 2 plus 3 is, your next person next to you is going to be given 3 plus 4. I've had some students do what you're suggesting and put down the answers for the person who sat next to them. They failed. I warned them in advance. If they're not realizing that they need to look at the question that they've been given and answer that, I think it's okay.
Another one too, William asked about, and I think you're getting at this about the question. So you have this technology, and having the technology, the app. His question is, how does the student know what questions to ask the machine to do?
That's what we talk about in class. I show you a lot of examples. And we're going to be doing some of that in this presentation. Okay? So let's start with a very, very simple app. You want the area of a rectangle. Without the app, you need a formula. Area is equal to length times width. 3 variables in there are area, the length, and the width. Knowing any 2 of these allows you to calculate the third, because area is equal to length times width equals area divided by width equals area divided by length. And these are the concepts that I want you to understand. But when we go to the app, what we're going to do is, let's do it. See, I gotta get the link to the app. And that's not working. I'm going to stop the share and do it this way. And this is part of what they need to understand, is that technology doesn't always work right away. And therefore, you have to understand what you're doing in order to get the technology to work for you. So we said we're looking for an app, and this is the example of the app, okay? The formula for carrying, when you click on it, this is what you get. And we're looking for slideshow. No, it doesn't give me something example. So let's say the length was 4 and the width was 6. And we wanted to know the area. We're going to click on area. I hope you can see it now. So 4 times 6 is 24 because everything was in inches. What if the length was in feet? And I want the answer to come out in meters. It'll do the conversions for you. It'll do all the calculations for you. You can get, if you give it any 2 of those with the appropriate units, it'll give you the answer in whatever other units you want. Now, I'm telling you that if you're out there in the real world, you're going to have tools like this available to you. You don't need to know that there are 12 inches to a foot or how many feet there are to a mile or any of that other stuff, because it's all there for you. But you'd have to be aware that there are different ways of measuring things, that when you're comparing two lengths, you could either put it in inches or feet or in miles. And if you aren't aware that these units are relevant, that's what's going to hurt you. Okay, so now are we back to this thing here? Or maybe not. Let's share it. Financial calculator. Suppose you deposit $500 into a savings account that pays 2.5% per year, credited on a monthly basis. How much money will you have after 5 years? And on each one of these, we're going to be looking at a calculator where you put in the information that you have, click on the right button, and it gives you the answer. And this is what you're going to have when you're on the job, whenever you're doing anything else. So area rectangle we already did. I know what I can do. I can share my whole desktop. Let's do that. Okay, so now, different app. You get to put in what you want. 2.5% interest rate, 6 years, 12 periods per year. And what do you want to calculate? You want to, starting with $500, your final balance is going to be $566.50. And it gives you displays what you have at the end of each month, how much interest you earned each month. So if we go back and look at the next one, I borrowed $500 to be repaid with 4.3% APR over 3 years. Oops.
As you're working on this, I'm just going to read off Ted's question. So keep
Yes,
going.
yes.
He's just wondering what happens if the technology fails, basically. You know, your calculator battery runs out. So,
All right. Let me ask Ted the question. What do you do when Zoom crashes on you?
We have to wait for the Zoom crash to be
Correct.
repaired.
Correct. And that's my whole point, is that this is something you're having to do with everything in life today. If your car dies, you got to pull out your smartphone, call for an Uber, call for AAA to have it towed away. You have to learn how to respond to these issues. Yes, things do go bad, but that's just part of life. Mathematics cannot be so far separated from life that the things we use will never fail. A pencil point can break on you. Anyway, the problem was we started with a negative $500 starting balance. There's the interest rate, how many years, and you want to know what your periodic payment will be to get a final balance of 0. So we're going to click that, and it says if you pay $14.82 every period, now then you say this one just gives you the first 10 and the last 10 payments. What happens, you say, if a person doesn't understand about rounding? Well, that happens in savings and loan. I walked into savings and loan. I said, this is what you told me the interest would be, and this is how much you gave me. And the lady had to go talk to her supervisor to find out that the answer was rounded to the nearest penny. But that's the same thing that you've got when you're doing your taxes. It's rounded to the nearest dollar.
we have another question
Yes.
from, I think, am I pronouncing this right, Xiaoying? Please interrupt me if that's incorrect, but what happens about, like, the question is essentially about student understanding of whether this answer makes sense. What if they get a huge number that doesn't make sense because there was some kind of typo? How do you help students learn to identify that the answer does not make sense?
Usually I start by saying, suppose I paid you $1 a week every week for the next 3 weeks. How much is that going to be? They say 1, 2, that'll be $3. Okay, what if it was $10? How much would you get? $30. What I try to get them to understand is that a lot of these discussions can be had by approximating a value. So if the number is going to be just a little bit over $10, maybe $15, you don't really know what it's going to be, but you know it's not going to be as much as if you had $1,000. Basically, this is exactly this kind of skill that I'm trying to emphasize, is you need to be able to approximate numbers and recognize whether the answer you come up with makes sense or doesn't. Now, having said that, many of you may remember that there have been major problems when Mars landers crashed because the units they were being given were incompatible. The people from Britain were thinking we're measuring things in kilometers, and the people in the United States were measuring them in miles. And I'm explaining to them that this communication of information is critical. I've got $10 at the beginning of every month into account that pays a certain interest rate. How much will you have after 42 months? Well, 42 months times 10, it'd be a little over $400. So it's $420 plus the accumulated interest. And that's something you can do on your fingers. When we actually want to look at the answer, it's not coming up with it at the moment. Oh, there it is. So we're making a $10 deposit every month. There's the interest rate, how many periods, number of periods per year, 12 periods per year. We sit there and we look at what each one of these things mean. And I explain to them that's what you're going to have to do in life also. Or when you walk up to your microwave oven, the microwave oven is asking you for how long it's going to cook. You need to recognize how to put that in there. Then we click on calculate to get a final balance, and I show you, see, the first month you put in $10. There was no interest earned. Second month, you've got the $10 in there. You earn 1 cent on it, put in another 10. Now you've got $20.01. And we go through this step by step to try to get them to understand that at the end of 9 months, they'll have a little over $90. This is the kind of approximating that you have to do in order to find out whether your answer makes sense. And then later on, when you at the very end, at the end of 42 months, we said it'd be a little over $420. It's actually $432.43. And that's what we're trying to do, is to get you to recognize what's going on. Oh, wow.
Couple more questions for you,
Go ahead.
Julius. Mark typed in the chat that to him it sounds like it's less teaching how to understand mathematics and more developing life or technology skills. So it's important, it's not the same thing. Also, wouldn't this still be falling into the same pitfalls as you're trying to avoid? Students memorize that this type of problem, I use this program, and they're still not necessarily able to translate those skills to other areas.
That has not been my experience. In fact, I've had several students come back to me after my gen ed class, telling me that not only did they benefit from the class itself, but they've taken the same skill set and applied it in other areas. One person said that he got an A in English 102 because he was applying the kind of thinking process that I got him to use in Math 118. So that's not been my experience. I agree that that is what I want. I think I'm getting it.
And I had a question. You were talking about the value of estimation. Do you ever explicitly assess their estimation skills?
Nope.
Okay.
The only reason is when you take a test and you put down an answer that makes no sense at all. We're talking probability. Probability has to be between 0 and 100%, right? And if you tell me the probability is 32, I look at you and say, 32 what? I try to get them to think. Can you explain to me what 32 means? The 32 can't be a probability. A probability is something out of something else. One variable statistics. I give them this poem. Hey, diddle diddle, the median's the middle. You add and divide for the mean. The mode is the one that appears the most, and the range is the difference between. So what is the mean for this set of data? And I look at it and I say, so here's my calculator. There's the data. You put in the data. The neat thing about this calculator is that you don't have to figure out what button to push. It gives you all the answers. It gives you the mean, the median, the mid-range. You have to be able to read this thing. And if I ask you for the coefficient of variation, you have to be able to go down this thing and find that the coefficient of variation is 47.88. Now then, typically, if you have a calculator, you have to push different buttons to calculate these things. The mean, the median, the mid-range. I say that's not realistic. What's more realistic is give them all the answers and have them figure out what was asked for. And typically, when they get something wrong, we go back to the test and I tell them to take their index finger and let's point to each word in the question, one word at a time, and let's see what it's really asking for. And that's when they say, oh, I missed that word. That's what I'm trying to get them to recognize, is that missing a word is what is the cause of most people's problems. Discrete probability. In real life, math is only going to be a tool. Business analyst uses present value or future value. Real estate agents use amortization tables. everybody has a different set of numbers to calculate. In your personal life, you're going to be baking or sewing or managing money. Each one of these, you're going to have a tool to use. You don't want to have to figure out how to do the operation. You want to figure out how to understand things of that nature. Anyway, the teaching of math at secondary and post-secondary levels should evolve to explore and understand basic mathematical concepts while providing students an introduction to the application of tools similar to what they will use in their careers and their lives. And that's what I'm trying to get at, is that you need to look at what these students are going to be doing with the math you're teaching them. And if nothing else, maybe you should go make some friends who work on a job and look at what they do. Find out how they're using the math that you gave them. If they're not using it the way you thought they were, what are you going to do about it? Anyway,
There
thank
was
you.
one, yeah, thank you. Thank you so much, Julius. There was one question I thought maybe we could all chime in, that America made this really good point about, we're talking about these higher level thinking, so right now it sounds to me like Julius is more assessing, like you're giving them a traditional question and seeing if they can find the right tool to answer it. But how, I don't know if anyone else has any thoughts about how you assess these higher level thinking about, is this a reasonable answer? I don't know if that's what you were talking about, America. So I don't know if anyone else wants to chime in, or if we want to let, if Julius, if you have thoughts about that.
I'm constantly trying to answer that question myself. So if anyone has any suggestions on what I might do, please.
Yeah, I think about the estimation in terms of that specifically. I think you could directly assess that. You can ask for estimates. You could do some things where they're quick. Let's see, America has in the chat here, if it's a question type they've seen before on the test, they've already solved the problem before they start. So if it's a novel question type, then it feels unfair. So that's interesting. So I think, yeah.
And I do plenty of that also, where I'll ask them a question where they have to figure out what it is I'm talking about. Yes.
William's wondering what your thoughts are on standardized testing.
How do I say this? One of my most exciting experiences when a student came to me and said, you know that test you gave us last week? I said, yeah. Well, I just went to the internet and found that somebody had posted it with all the answers and the information worked out. So standardized testing is one of those things that may check to see if a student is smart enough to figure out how to get the answers some other way, but it's not going to test what I want, which is, here's something that I want you to understand and figure out what the answer is.
I think if you look in the chat here, I think William is specifically wondering about those, the ACT, SAT, etc. Yeah.
And I think those are a mistake, because those are the kind of things that can be, if I were programming an AI robot, then that's how I would test it. Yes. But I'm not trying to program a robot into going through certain steps and coming up with an answer. I want to give them something they may have never seen before in their lives and try to explain what they're doing with it. A lot of times the explanation is much more important to me than the actual answer they came up with. Graduate record exam, same thing. Testing is something that you do to equipment to see if it works. You run it over and over again and see if it breaks. Testing is not something you do to people.
Any other questions or thoughts today?
Anyway, the app that I was demonstrating is called Wright Calc, and it does a lot of interesting things. If you can think of something else it should do, so for example, one of my colleagues wanted to know how to calculate required office hours, and I added functionality that did that. Basically, if you have a problem that you need solved, you should be able to get somebody like me to write you the code that's going to give you the answers. You shouldn't have to sit there with a slide rule and figure out how we convert this number to a base 10 log. Oh, by the way, why do we still have base 10 logs on our calculators? Base 10 logarithm is totally useless. It was very, very important when we were doing calculations with a slide rule or using log tables. Not anymore. One of the first things I would throw out the window right now would be base 10 logarithms. Natural logs are the only things we should be using. What do you think, Mike?
Oh, go ahead. Go ahead, Tony.
Okay, whichever, Mike.
Yeah.
I still, a lot of it depends what you're doing, because if you're really doing like a gen ed math class, there's really no reason. I'd never do logs in that class to begin with. Now,
Right.
when you're doing a college algebra pre-calc class, yes, you're doing the logs in that class because you need them for certain applications, bring exponents down, everything else. It all depends on what you're working with or doing.
And where would you ever use base 10 logs?
Or you do like derivatives, bringing down the exponents and that, so they're easier to work with those types of calculations.
Natural logs. Base 10 logs, no.
Mm-hmm.
Now,
I know that's the logs you usually use, but you want all the other logs out there.
You could use base 10 logs, could come into play if you were working with order of magnitude estimates.
Yeah, see, there's places.
I'm not saying that that's a common application of logarithms,
yes,
mind you, but that is one application.
You're totally right. Now,
Richter scale.
Back when I went to school, I actually had to memorize the logarithm of 2 is 0.30103. The logarithm of 3 is 0.4771. So things change over the years. All I'm suggesting is that we have not been changing what we're teaching to take advantage of the new functions that are available.
Tim asked earlier what your thoughts were about helping students learn how to use Excel.
I do
your
that.
Thoughts on that?
I do that in some of my Math 118 classes. It depends on what they express an interest in. One student actually had me show them the code that I used on these apps. The apps are all written in JavaScript, and you can have your browser display the instructions that I wrote. And so I showed them, see, here's where I tell it to add these two numbers, A equals B plus C. So yes, if I can get a student interested in something like that, I'll even tell them to stay after class and I'll show you the answers for how to do the Excel, how to do anything.
That's excellent. I'm going to just make a couple of reminders for people. We've been trying to let everybody know about the scholarship fundraiser. So we're trying to tell everybody who's hosting to paste those details. So there's a Facebook page that has a list of all the prizes. I don't think you need to have a Facebook account to view that. But the way you purchase tickets now, Tony's out of business this year. We're just going to the IMACC page and making a donation via PayPal. And then you get 1 ticket for $1 or 6 tickets for $5. And then if you want them to go toward this, it's just a raffle. So if you want to go toward those specific prizes, you just the details are on the Facebook page about how to. So if there are no further questions, thank you so much, Julius, for your time today and for all the excellent questions that people popped in here. We really appreciate it.
So
right.
I'm looking at your Facebook page right now.
Mm-hmm.
And it says IMACC Memorial Fund Scholarship Raffle, April 2, online event. Join the event. Yes.
Mm-hmm. Yep, yep. And there, if you go to the discussion on the page, then there are pictures of all the different prizes that have been
Very good. Yes, I'm seeing that.
Cool. All right. Thanks, everybody. I know we have some committee meetings after this for those that are on committees, and then we have more sessions next Friday. Schedule is on the webpage. You clearly know how to find that because you are here.
See you next week.
Thanks, everyone.
Goodbye.